I'll let her know that we're struggling. I will definitely let her know. So that's what that looks like. Here's what we just talked about. Wondering. It was. Over the weekend, I assume it was over that, cause I just looked at it. But yeah, I'll let her know. We came in here with the thermometer. We could definitely see what it's looking like. So yes, here's 3.2. You'll be able to understand the rules of vector addition, subtraction, and multiplication. Apply graphical methods of vector addition and subtraction to determine the displacement of moving objects. Displacement can be determined graphically using a scale map, such as this one on the Hawaiian Islands. A journey from Hawaii to Malakai has a number of legs or journey segments. These segments can be added graphically with the ruler to determine the total two-dimensional displacement of the journey. So you'll see, in order to get there, they had to go north, and then northeast, and then north, and then northwest, and then further northwest. But for our straight line, we could really just see what our straight line path would be. But you can add up all these components to see what we're about to learn. A vector is what's a vector? I moved away from it. What's a vector?
That triangle thing we were looking at?
It's you can put it in a triangle, and hey, great day. You can put it in a triangle and understand the hypotenuse, and hey, everybody got their hair done but me. Hey. I gotta get mine done. Vector is which one?
The dotted line.
The dotted line.
It's like the
I mean, there you go. There you go. Magnitude, and what else needs to be displayed for magnitude? That's more magnitude.
The position.
That's pretty much magnitude.
The space or the direction.
Direction. There we go. Magnitude and direction. Vectors. Magnitude and direction. Always remember that with vectors. What's a scalar? What does scalar mean?
Scale.
Right? Which a scale shows us
The value.
right one thing, one amount, right? One length, or we typically say weight for like the scale. But anyway, it's the amount. It's just the magnitude. Okay, so that's the difference between those two. So that's one of the big things that we gotta learn is they might say, like, just give us a scalar representation. So and then it's like, oh, okay, I just need to say what it is. I just need to say what the amount is. But they might say, explain to me in vectors, in vector form, what our magnitude and direction is. So now we're about to learn vectors in 2 dimensions. Vector is a quantity that has magnitude and direction. Displacement, velocity, acceleration, and force, for example, are all vectors. So that's something that's very important. So and then here's our graphical direction. So just like we were saying that the helicopter is going straight that way, you know, so we had an X. We had an X and a Y. So always remember, they're about to tell us here in a second, but always remember that a vector is gonna have an arrow. Since it has a magnitude and direction, we're gonna have to put that I walked 9 blocks east. So nine blocks east. And then you gotta put that direction, because I gotta know what my direction is. And then we walk 5 blocks north. All right, so I know it's a little sloppy, but you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5. So in the last example, we saw, okay, the helicopter just needs to go this way. So there's a few things that we've found here. We've made a triangle, like you said, we've been able to make a triangle. As we create our vectors, we're able to look at a trigonometric function. So we're able to see the triangle. So now, remember, these will be head to tail. Head to tail. So that's something while adding, So that means that the head of the arrow, the tip of the arrow here, is gonna be connected with the tail of my next. So I could call this A, and then I could call this B. So and then I could call that C. So and then the reason that I want to see for the understanding of what's the most efficient path. Y'all know what the most efficient path is? A straight line, yeah. So instead of going right up, I could just have a straight line. So here's our helicopter. So what's 9 plus 5? It's gonna be 14 blocks. But then, as y'all saw a little earlier, what is the helicopter gonna be going here now? 10.3. How do we figure that out? We'll be getting there in a second. So then I have a theta. So now it's looking a little bit more scientific here. So and then in the next chapter, we'll be able to look at some of these things even more analytically, a little bit more scientifically. So it says 29.1. There's some protractors. I meant to grab a protractor. Oh, I think I do have a protractor in here. Well, no, so on our protractor, we'll be able to see, oh, okay, that's 29 degrees above. So in the first part of chapter 3, we're just showing, oh, okay, here's a vector, magnitude and direction. Then we're saying, okay, let me graph it, and then I could use a protractor to look at it. And then for the next part, we'll get down to a little bit of the math, but we'll break it down, not make it so complicated. So and then like we were saying, head to tail, putting them together. So, and then our head end of our C, that's where our destination would be. So that's what they're saying the destination is. All right. So, yep.
Oh,
Yeah. So, and then we would put the middle part of the protractor onto our starting position, and then since we've already been able to draw a line of where our location is at the end. Yeah. So that's how you could measure the angle physically. So that's what this is talking about, head to tail method. So to the right and then the north, and then we're able to just draw it together. So that's what that's talking about. So this is the same thing. Use a graphical technique for adding vectors to find the total displacement of a person who walks the following 3 paths. Displacement on a flat field. First, she walks 25 meters in a direction 49 degrees north of east. Then she walks 23 meters heading 15 degrees north of east. Finally, she turns and walks 32 meters in a direction 68 degrees south of east. So use the graphical technique for adding vectors to find the total displacement. Okay. So that's what they want us to do. I think there's another example that you all could try. Well, we could work on that. Represent each displacement vector graphically with an arrow, labeling the first A, the second B, and the third C, making the lengths proportional to the distance and the direction that's specified relative to an east-west line. The head-to-tail method outlined above will give a way to determine the magnitude and direction of the resultant displacement, denoted R. Alright, so first she walks 25 meters in a direction 49 degrees north of east. See if we can get some. So we'll do. We could do it 1, 2, 3. All right. So we got that. Boom, boom, boom. Boom, boom. Alright, X, Y. Alright. So we want 25 meters in a direction 49 degrees north of east. So I can either do 25 notches or
You can still get some 5.
I was just thinking the same thing. Great minds think alike. 5, 10, 25, 5, 10, 15, 20, 25. And then I'll technically need the magnitude of Y, but alright, so let's get our fresh volunteer to test out doing some so we can work together. It'll be real quick. She walks 25 meters in a direction of 49 degrees. How would I put that in the graph?
She
Yeah,
walked.
no, because how we gonna know 49 degrees? Well, I guess we know because
we
it's a
can just
right angle.
estimate. Yeah, right angle is 90 degrees. So and then
So it's a little over half.
Half of
Right.
it. Yeah.
So glad you guys are catching. Me too. I'm so glad you're catching.
Yeah, it's easy, but I just don't have like the protractor.
I think. I'm gonna ask her when we go. I'm be like, cause he put it all together like on the thing. I'm like, I don't think just put it in with the please. Cause yours is like that too. The same 16.5 when it comes.
so then if it's something that's greater than
Okay, I think I know how to do it because then all you gotta do is just put it at 25 and then you mark it right there and you make a line.
yeah.
Okay.
So
But the only thing is, But the only thing is, I'm gonna have to draw the compass because I get confused with north, east, south, west. So I'm gonna have to draw it out so I can
Yeah.
remember.
you know, Yeah, what? alright. Just a little active participation thing. Alright, so there's our compass. And then those are a few of the 45 and then something like that. Maybe 30 and then after 30 you got 60. And then we know what a straight line is.
180.
Yeah.
Yeah.
What's it?
So this is gonna be 80 degrees. So then anything through here, we're just gonna be looking at there.
Oh, it's J-Mac. J-Mac.
This is J Breezy.
Oh, I always got something about me. Oh, that was why I came with you.
Alright, let's go ahead and so you said you could go ahead and do the first one.
Yeah.
Do it
I
real
do
quick.
it.
Just a little active little participation thing, get our blood flowing.
Okay.
Alright.
Thank you.
Are you a Leo too?
Yes. You Leo?
No, my mom.
Oh, really?
Yeah.
Oh, Leo.
July 30th.
Oh, okay. My birthday August 9th. That's
August 9th.
Yeah. Okay, so I'm gonna put this one like kind of. I would just say, that's like kind of half, huh?
So and then the magnitude, what's the magnitude?
The magnitude is.
First she walks 25 meters.
Yeah,
Yeah.
25 meters. North, right?
Correct.
So that's right here at 49 degrees. In this theta, it's theta 49 degrees,
Right.
right? Okay.
Yeah. Yeah.
Okay.
Technically that would be like north of the east, you know, but yeah.
Oh, so I should have just,
No, you did it perfect. You did it
Oh.
perfect.
okay, 25 meters.
Yeah.
That's it, right?
Boom.
Okay.
Congratulations.
I
You
ain't
just,
seen
Oh.
you just did a vector.
Can you explain?
So-
Oh, wait, I should put an arrow, yeah.
Yeah. Boom.
Okay.
Can you explain that, please?
Yeah.
Okay,
Okay, let me do the next one because it's easy, y'all, for real.
It
So,
seems easy.
You know
but
what?
it
Say it
seems
on the side because I ain't
I'm
seen
sorry.
what you're doing.
I'm like, is
Okay.
it too easy to where I'm
I
like,
want-
oh,
Yeah, it's y'all.
It's pretty
Okay,
it's
so
pretty
it's
simple.
23 meters. So she gonna be walking this way, but hold on, wait. I gotta see
Well,
because.
can you explain the first one first?
All right, I'll explain the first one. So she walks north, right, 25
In
meters.
direction of 49. Okay.
And say
And-
say north of east, because
North
if you
of
say
east.
north,
I'm
then
sorry, okay.
straight up.
yeah.
North of east. So she walks 25 meters north of east at 49 degrees. So this is 90 degrees. So basically I just made it a little bit up so it can be 49.
Yeah, half of 90 is 45.
But this is, I don't know how they explain it, but I know
Okay,
this
yeah.
is like the vector thing or
that's
the
90.
graph,
Mhm.
and it's at 49 degrees.
Mm-hmm.
And this is always gonna be 90, so wherever it is, it's gonna be 90, and then you just, it's gonna be easier when we have a protractor. But, yeah, and then she walks 25 meters north of east. So this is by fives, so just count by fives, and then you go north of east.
Oh, gotcha. Thank
See,
you.
north of east, like that way.
Good job.
Because we started from there.
So the second one, that was the first one. The second one is
Mm-hmm.
23. Is that what we agreed?
It's 23 meters, so she's gonna be walking. Well, hold on, wait, because
Then she walks.
no, it's north of east, right? Oh, so it's the same, right?
Yeah, it's north of east too.
Okay, 15 degrees. So 15 degrees, like.
15.
um,
Oh.
I'm confused because, okay, so 90 is, oh, okay, no, so what's this little box? That's 45, right? This a little small one?
So we're
This little line right here is 45 degrees.
Okay.
So really, you just guesstimating.
I'm like,
Yeah, we just.
Yeah, because we don't have a protractor.
We don't really know.
Okay.
oh, okay. Well, yeah,
So this is.
But we write in degrees so we can know what
Meters. North,
yeah, the thing, okay. Yeah, the
east,
thing. Got it.
at 15 degrees.
Finally, she turns on study two.
Represent east.
Let me see.
But so really.
Wait, hold on. No,
Okay.
Because this is south of east.
Rather than the vectors.
How you gonna write
or whatever.
arrow? What we want arrow down?
Yeah, protractor.
So south of east.
The arrow ain't going down. Is
So you're gonna have to, yeah, I think, I
It would?
I
Yeah, it
would,
will.
yeah,
It would,
it
okay.
would look like that.
Because I was like,
Yeah,
that's
it will.
going south to east, so I would start doing that.
Nah, you could. Well,
Huh?
technically, because it's like, okay, she's going up, and then from there she's going, over. So next we'll put them all together. But
Oh,
but
so
just
she's moving this to this, and then it just basically be like
yeah, just go
a
from
little
there.
bit here type shit.
Oh, so
Well,
we taking
if-
all
if
three
it's-
lines
if
and
it's
making
south
one
of
triangle?
east, that's
Yeah,
not
again,
north of
triangle.
east.
Oh, so
Yeah.
that triangle, that
So
would
technically
be
it-
that
it's
way.
still
all the way
within.
to this
I didn't know if you want me to go outside of the graph
Yeah,
though.
we can, it'll be an imaginary. Yeah, just keep on going. Just keep going that down. Cause
Yeah, straight down, no, straight
yeah,
down.
cause we'll complete.
It's gonna look
the,
like this because it gotta
we'll
be
com-
south,
Yeah,
I think. Oh.
Yeah. So we'll
Wait.
just complete the
Oh, south of east.
coordinate system.
I don't like that. It's not straight enough.
Yeah.
Wait. This the only thing I get confused with is the compass thing, because if she's going south of east, that means she's going from here, so she's going down this way.
Yeah. Yeah. So this is y. So there's a positive y and then a negative y.
Okay.
So just right. So and then x will be in the middle, like that. Right. And then we'll always
could
know that
do
there's
that
a
You don't have
negative
to,
exit. But yeah. So that's our compass. North,
Okay.
east,
So
south,
since she's
west.
going southeast, this right here would be the southeast, right?
Mm. Correct. Yeah. On this side. You said it's going to.
I got what you're saying now. Okay, I got what you're saying.
Yeah,
So we
yeah.
finished the graph to go long ways, but she's
Right.
going, that's not.
So what's the?
But she's going
Finally, she turned
68
and walks.
degrees south of
68
east at
degrees
32
south of
meters. So you
east.
gotta put the 5, 10, 15,
On the x-axis or the y-axis?
That'll be X.
18.
So
X is
five-
going to be our
Would you say
magnitude.
5, 10, 15?
We're going to 32. So 5, 10,
Well, go to
15,
35.
20, 25, 30, and then
35.
35 will be at the end. Yeah, that's cool.
Yeah.
35. Perfect.
So the line is gonna stop right there?
All right, so now we got to look at, so it's 32 meters. So we know how far it's going to go because we'll go somewhere in between 30 and 35. But then we got to look at the direction, 68 degrees southeast. So I had so half of 90 is going to be 45. So then we're getting closer to 60, and it's the same on the other side. So half of, so then that's 90. So then we got 30 where it's shorter. You got 45 where it's halfway, and you got 60.
Yeah, I was, closer to the Y line.
Correct.
Yeah.
You were right. I just wanted to.
It's fine.
I just wanted to break it down.
Is that close enough? Well,
No, because you gotta
girl, I'm
go.
right
Oh,
right there.
you gotta go to 32.
32, yeah, you're right, okay. I'm talking about close enough to the Y,
Mm-hmm.
but I do gotta go to.
So that means it's just magnitude. So,
Yeah, all
so
the
you were
way down
technically,
there, yeah.
so you're technically good. Just gotta. Your angle was pretty good.
Okay, I'm gonna stop injuring.
Yeah, it's all good.
That's fine. It's so curved. Y'all
Okay,
get the
it's fine,
picture.
just
Y'all get the
put the-
picture.
Put the dots though. Like
You know
where
my
it's
first
at.
quiz, what first test?
Yeah.
Okay.
Yeah.
Yes, ma'am.
That's cool. We're not using a ruler and protractor right now. Just wanted to kind of let y'all get some.
That's about as good as it's gonna get. I ain't gonna lie to you. What is it,
Some
32?
direct work.
Calculation,
And then this right here will be the, what is it, 68?
Direct experience.
Okay.
What you got that 0 for?
That's theta. Oh,
Oh,
32.
degrees?
Oh,
Oh,
point.
no.
Oh, okay.
Oh, okay.
Got you. Good look. Boom. Great. All right, bet. So,
The southeast been confusing though.
That's the only thing I be getting confused
The
on.
whole
Yeah.
going down,
Yeah,
that's the
the-
thing I got confused on, but
They
it
have
is.
gotta look like that for this.
the dotted line is our where we're going from the
This
from
was
the
at
edge.
32
It's the-
meters.
It's the magnitude.
That was just me
32
showing
meters.
y'all the line, cause my stuff was crooked.
And she didn't put the numbers, but it's supposed to be like the second one, the 5, 10, 15, 20. It's at
so the
Yeah.
5 to 50 is supposed to be the dot line.
yeah, that's fine. Okay,
The
you gotta do it.
32
Oh.
is just me, the dotted line is just showing you the direction of where it's stopping. That's why I put 32 meters next to the dotted line so y'all can see exactly where it was at.
Yeah. So
Okay.
this is so boom, great job, y'all did it perfectly. Boom, boom,
Good job, yo.
good job. So this is how it would look. Place the vectors head to tail, retaining both their initial magnitude and direction. So that's why I wanted y'all to do this first, so that way that won't look so crazy, you know. So that way it's not like, wait, hold up, we skipped, like what? All right, so boom, the A, the B, and the C are put together.
Ain't even a triangle no more. It look like a rhombus.
Right, it does look like a different. It does look like a different
Oh,
one.
slant it up. It's a fold. It look like a fold something shape.
I used to tell you.
It's still got
It ain't even no triangle.
But now, you know, our resultant. But you can still do. You know, it's still gonna be a resultant. It's still gonna result in what we want. If it's too far for y'all, yeah.
You can